Good morning, mathematicians. How's it going? We have some juicy new math drama just dropped. Oh, I forgot to pull up chat. Gotta give me a second. Juicy new math drama. Yeah, so George Lustig is firing shots at Kashiwara. Oh no, did my computer freeze? Uh-oh. Gang, are you still with me? Hello, Edit Smith. Hello. Yeah, so basically, as you can see in the document, clarifies the historical development of canonical basis. Such a clarification is necessary. Says that Kashiwara repeatedly made misleading claims about priority. Yeah. And you can see some bold stuff. I mean, presumably he's not wrong. Presumably, Lustig is not wrong about what's going on here. But also, yeah, I don't know. Also kind of wild to be putting out a paper like this on Archive. Maybe this sort of thing has happened before. I don't know. But a friend of mine did say something very funny, because there's somewhere he was like, yeah, I don't follow a lot of, yeah, he's like, I don't follow a lot of math drama, but I think it's really funny that that he brought up an argument that he had at his birthday 19 years ago. So I mean, yeah, maybe he's not wrong. Maybe all of these things are accurate. But this is also like kind of wild. In 1995, yeah. Mind you, okay, this isn't so bad because it's in a paper. I guess he's saying that the claim is in a paper, so that's fine. Maybe you go back and you look it up. But what is wild is to be like, oh yeah, I remember my birthday party 19 years ago. Anyways, what do people on Reddit have to say? Yeah, exactly. That's what I said. Interesting. Yeah, you gotta pick your side. Oh, the second big fight you've seen on Archive. Oh, are we getting more drama? Juicy. I love it. Here for the math gossip. Wow, drama within drama. The girls are fighting. I love it. Yeah, more math wars. I shouldn't be asking for this. I don't want to get caught up in a math war myself one day. In this note, we provide the comments on the paper, a note on the hit polynomial problem for the polynomial algebra. We show that some results in this paper are not new and others are false. Bam. Devastating. Yeah, I mean, my next preprint that's going to go up will have some results that aren't new. But I'm trying to make sure they won't have results that are false. So, don't come at me, guys. Don't come at me about it. P be a prime, mod P Steenrod algebra. No idea what that is. In the paper 3, the authors presented some results on generators and applied them, is well known. You wouldn't take any of this math drama seriously until it gets published? You mean this one I'm looking at now? Yeah. Well, I don't know. Is there so they point to 3, and let's see. 3. I mean, this does look like it's published. This does look like published mathematics. So, oh wait. Oh, I didn't see the /s there. Hence, theorem 2.1 is only a special case of theorem 1.1. It is not new. Is what drama? Or what fake news? You mean Lustig's thing? I mean, he seems to have documentation. He seems to have documentation backing up a lot of his things, right? Kashiwara is the guy who got the Abel Prize recently. Absolutely. Yeah. But, I mean, Lustig is also a powerhouse in his own right. Go look at his publications. They are many. They are many, involving a lot of very complicated math. So, yeah. Well, I don't think they'll take it away. I don't know. I mean, he does point out that I think some of the stuff surrounding the Abel Prize does specifically mention things about these bases in relation to Kashiwara. But I mean, the Abel Prize is not just awarded because you discovered one thing. I mean, it's awarded because you had a long career with many important ideas. So I don't think they would take yeah, I don't think there's any reason to, if this is all like assuming Lustig's 100% right on every single point. Yeah, I don't think it takes away from the rest of Kashiwara's career, unless he took all that too. But I don't think so. There's other lesser known drama though. Point 3 is interesting. They say there are serious mistakes in theorem 2.4. Which, sure, I don't know. Maybe if we go look at it, but at least list some of the mistakes. Ooh, boom! This is the most devastating, like, this is the most devastating thing you can say to a mathematician. This is the most devastating thing. Like, imagine the most deep cutting line you've ever heard in a rap battle. Like, this is that. Moreover, the result of this theorem is trivial. However, it's stated with a proof. However, its statement is also not correct. Oh, what a takedown! This is a real takedown. Hello, Lucian. Welcome. Today we're reviewing the latest math drama. I mean, maybe we'll start doing actual math in a minute if someone has a question. Or, I'll start ranting about various things. But this is pretty juicy. This is pretty good. Crossly presented example substantially overlaps. However, the author does not cite the paper. The proof is false because the author wrote this with this, hence the relation is false. What's the other thing I'm thinking about right now too at this point is that if this is a published paper, I mean this is kind of on the journal. If I was the referee, what would be the verdict? I don't know. I mean, I'd have to go look at the actual paper, and then of course there's the problem that this is not my area. Although I mean, I could probably understand some of the stuff. I went and looked up some of the definitions. I mean, it doesn't seem like it's anything too crazy, right? It's like there's some elements of a module and you're trying to prove you have a basis. So but speaking of the referee, I mean, if all of these proofs are if everything they're saying here is accurate, then I think this is just as much an indictment of the journal as it is of the mathematicians who published this paper. Oh, wait, what did I say? We use an algorithm on Magma and find invariant has dimension 1 for every S. Wow. Okay, this next line is amazing. Oh my god, this is amazing. However, we do not believe there's a computer program that can check these results for infinitely many values of odd numbers p. Brutal. Oh, that is good. That is good. Wow. Oh my god. Oh my god. Wow. Okay, now I do kind of want to get wrapped up in some controversy, in some math beef. Wow. Wow. That is devastating. Absolutely devastating. Absolutely devastating. Yeah, what is this journal? What is this journal? So let's see the paper in question here. This is okay. I mean, in some sense, the uh, um, Harvard University. It's hosted by their publishing, some publisher related to them. Really? Okay, this is the journal, I guess. Maybe we can look up. Well, well, Arad, I mean, uh, no, but I mean, for infinitely many values, they're being cheeky, right? Of course, there's no program that can verify something for infinitely many numbers. This is impossible, right? So, so they're being cheeky here when they say we do not believe there's a computer program that can check these results for infinitely many values of odd prime numbers. They're saying what they're actually saying is this is completely batshit crazy because you can't possibly use a computer to verify this thing. But they're being subtle and cheeky about it, and that's why I love this sentence so much. Because yeah, you can't, you can't, yeah. Endersteph, this is well, the context is there's a Reddit post here talking about an archive paper that went up where George Lustig, very famous mathematician, very much has done important work in my area of mathematics as well as others, claims that Kashiwara, who recently won the Abel Prize, he basically is pointing out a whole bunch of times when he says Kashiwara, claims to have done things about this canonical basis and crystal basis that he worked with before he did. And by all rights, I mean this should be. Oh, I didn't mean to. How do I delete the bookmark? I don't care about bookmarking this. But by all rights, like this is a feud between two very famous people, two big giants of mathematics. But what I'm way more interested in is actually this other feud. Someone posted in the comments here that they've seen the second big fight. I mean, okay, maybe these are names that are big in their field. I have no idea. But this is a more thoroughly destructive takedown, very detailed takedown of this one paper, and this is the most. I mean, this is just a beautiful sentence. Yes, this is the same Lustig from the Kasdan-Lustig hypothesis, indeed. Yeah, so the very focus of my thesis has this man's name in the title. Comment says, keep uploading preprints. So presumably there's more of it. Yeah, so this is only part of the story. Criticizing each other's work. Wow. Wow. Impact factor is 1.6. What's a good impact factor for a math journal? I have no idea. Okay, 2.0 or higher is considered good. So, yeah, I guess 1.6. This journal isn't. Journal maybe isn't so hot. As we can tell by, I mean, um, assuming that this takedown is correct, not a good look for the journal as well, I would say, as the researchers. Had the original blah 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 survey articles. Yeah. Anywho, great stuff. This is content that I live for. Yeah. I don't like dishing out gossip, but my God, uh when there is math when there is math gossip in the world, I eat it up. But here's an interesting question. Why is it often lower than the impact factor of journals and other disciplines? Come up with guesses. Papers are hard to read. Large number of subfields and only few people in each branch. A number of journals and papers is relatively high. Mixture of those. Yeah, I mean, that seems like a good guess. Who would have thunk mathematicians can get so savage? I mean, I did. I knew this. Mathematicians are brutal, you know? The true father of calculus, Newton's, oh my God. The disrespect of me forgetting this name, but Newton's instructor. Newton's mentor. Who is he? What's his name? Newton's mentor. He was a pirate. Isaac Barrow. Yeah, how could I ever forget a name like that? Yeah. Isaac Barrow. By the way, I don't think Isaac Barrow gets talked about enough in the discussion. Newton's mentor was vegan? Really? Oh, this post was deleted. Oh, wrong Newton. Digging the human history in tech. Yeah. Well, could you call this tech? In a sense, I mean, all of AI is calculus. But yeah, Isaac Barrow was a pirate. Did he get his eye stabbed out even? Or am I just confusing that with Newton poking things in his own eye? But yeah, Isaac Barrow was like a swashbuckler. He sailed the seas and like fought people with a sword. And there's a lot more to like the roots of calculus actually. Like Isaac Barrow knew a lot of these things that you might think is attributed to Newton. Of course, still Newton's a goat. And he put all these ideas together, but many of these ideas were floating around in the background since the ancient Greeks, and Isaac Barrow was close to putting a lot of these things together. The before tab. Wait, which one? Well, I'm going to go back to this tab for a second because I want to hear about all the different factors. A lot of different factors. For example, one theory is mathematics simply has less impact. That's also true. I mean, well, of course, there's pure and applied math, but yeah, I mean, yeah. There's a lot of pure math that just has low impact on other fields. That's also... wait, I got the joke? Wait, maybe I didn't get the joke. Sorry. Isn't that the point of research, though? Gluing things that were floating around and making them better and publishing? Yeah, I mean, that's true. That's true. But, we are often. I just mean that, like, there's often this talk of, like, this idea of the singular genius, right? And undoubtedly, there are people throughout history and alive today that are simply just unmatched by their peers in their genius. And undoubtedly, Newton was one of them. However, that can be true at the same time that one should recognize that these people like didn't exist in a vacuum, and there's maybe a tendency to believe, or the way that the story is told, it's like, oh, Newton like completely invented calculus or something, um, which like there's just so much more nuance to it, like the Greeks were basically on the cusp of infinitesimals like 2,000 years ago. Like some minor changes to the course of history could have resulted in calculus coming out 2,000 years ago instead of like 400 years ago or whatever it was. Yeah, behind every great mathematician there's a great advisor. What's my take on mathematics in black holes and quantum future? Don't totally know what you mean about that. I think general relativity is cool and is interesting mathematics. I have a textbook on general relativity that I would love an excuse to study more in depth one day, but let's be real, I don't know when that's ever going to happen. Unless I have a student, unless someone like hires me for tutoring and is like, I specifically want to learn about black holes, and then I somehow decide that, okay, I'm the right tutor for you, and instead of just passing you to a different tutor, I study hard to keep ahead of where you are in the book. That's maybe the most believable scenario in which I sit down and actually study that textbook. But I think it's cool. Yeah, that's about all I can say on it. I don't know what you mean by quantum future, unless you mean the future of merging quantum mechanics and general relativity, and then I really have no idea. Yeah. Yeah, I want to dive back into this for a second. 2-year cycle. Citations after 2 years do not count for impact factor. Oh. Oh, yeah. That's interesting. And a very good point. Publication can take a while. Size of the field, yeah, which basically the person said. Not that large of a field, fragments and subfields. Right. When someone makes a discovery in AG, you're not going to get a flood of mathematicians from other areas to take the next steps. Yeah. Absolutely true. I mean, yes. Doubt there's any conclusive or satisfying way to determine how each of these factors play. But I mean, I think all of these factor in for sure. Yeah. Maybe if I study general relativity right now, I could bend space-time enough that there's enough time for all the other stuff I want to learn. Maybe. It's a bit of a gamble, though. A bit of a gamble. Yeah. I mean, the tragedy is that I would still. Well, mind you, maybe it's fine. I was gonna say, the problem is that I would still like locally time runs the same for me. Um, but I guess if I made my clock slow down relative to everyone else's, then I could spend more time studying general relativity and then learn other stuff for fun. Um, but that also doesn't change the portion of my possible time experience of time. So I don't know. If someone cracks space time, then what could happen? Well, I don't know. I don't know what you mean by cracks space time. Space time isn't really a thing that can be cracked. So, luckily, you don't have to worry about it then. You're watching Buzzard's class. Oh, Kevin Buzzard's classes on Langlands. Been getting recommendations and found Charlotte Chan on representation theory. Also great lecture. Nice. Oh, and by the way, I watched 2 or maybe 3 of those. Named NPC. Of course, you can ask whatever you want at any point in time. You don't have to ask if you can ask. You can just ask. Now, will I necessarily answer your question? Maybe, maybe not. But you can ask whatever. You could ask the most unhinged things in this chat if you want. Well, maybe not the most unhinged things. If you ask something really insane, maybe I'll boot you. I don't know. But definitely, you can just ask any math problem you want at any point in time. But yeah, I watched the Cariani. Is that how you say her last name? Anna Cariani. I watched some of her lectures. Yeah. There's also a lecture series from James Arthur. It's like 20 videos long. It's from like last summer from Fields Institute. It'd be great if there was a group of mathematicians like Bourbaki that published YouTube videos instead of books from recent relative archive publications. That would be cool. But immediately, as I thought about that, I'm like, Jesus, that's way too much work. Way too much work. Yeah, named NPC. You should ask your question. Oh, there we go. Should I go about part B? Let's see. What's this name? Kat Snelson's linear algebra. A terse introduction to linear algebra. Page 151. Exercise 7.3.4. Wait a second. I'm in the wrong place. This is 7.6. Let me go. Okay. Let me go 7.3.4. So I don't know this notation here. Argv. Oh, because this is a complex number. I see. Right. Argv is this. And I argv is this. Part B of proposition. Oh, maybe, is this not the exercise? Is this the exercise? I don't know. Oh, it says 1 of 1. This must be the exercise. No, this doesn't look like an exercise. Oh, this is the draft. The original is behind a paywall. You'll post the problem instead. Okay. Well, the thing is, I think I'm gonna be logging off pretty soon, so I gotta get back to work on my own stuff. So, if you manage to post it right away, and it doesn't happen to take too long, then maybe there's a chance. But might have to save it for tomorrow's office hour. Be cool if someone could republish those old typewriter font books so you can finally read them. Yeah. Yeah. Yeah, you couldn't pay me to read those books. If one legend, a top caliber mathematician of all time, comes in today's era from Coffin and says, "Take me to the living legend mathematician," who would you send him to? Probably Schulze. Yeah. Maybe Lurie. I don't know. Yeah, honestly, nowadays, I'm sure it would be pretty easy. Some of these books, if you just like scanned them and then asked an AI to like techify, you'd still have to go through and like edit some stuff yourself, but probably do a lot of the job for you. Prove that if A is an n by n complex matrix that is unipotent, then there is a constant k such that all of the entries are bounded in absolute value by k j. Yeah, I don't know. I don't know if I can do this one off the top of my head. It seems like some matrix analysis stuff that I haven't done in a while. Hey, why isn't my writing pad working? A is a n by n complex matrix, and you want to prove that there exists a k, I guess a real number, such that all entries of a to the j are bounded in absolute value. So let's call it aj. I don't know. A B. A B is bounded in absolute value by k to. Sorry, I can't tell. Is that all in the exponent? This is j to the. J is to the m minus 1? Wait, what's m? What's m? Yeah, you're gonna need to. M is the nilpotency index for A. Okay. I see. But have I written this correctly? I think you need to maybe rewrite this a little more carefully. K times j to the m. Okay, so it's correct. Okay. What philosophy have I read? Very little, to be honest. Admittedly, mostly just terrible. My philosophy prof would roll in his grave, but just overviews of what philosophers think. But I have read. I did read The Republic many years ago. Awesome book. I loved it. Prove that this is true. Okay. Yeah, honestly, I have no idea where to start with this. I would probably just start with like, wait, unipotent? Or nilpotent. Wait. So the matrix is unipotent. The matrix is unipotent? Yeah. So I don't know. I would start with the identity matrix, maybe. Well, mind you, that's like too trivial, right? That's like too trivial. So what if we start with this matrix? What if we start with this matrix? Certainly, this is unipotent. Certainly, this is a unipotent matrix. And I guess M in this case would be 2. So we want to prove, so what, this to the J, that all of the entries are bounded by some constant times J. Yeah, which is trivial, yeah, because already once J equals 2, these are all zeros. These are all zeros. Yeah, so wait a second. Maybe is this expanding AI to the J and some bounding? Yeah, maybe. Oh, right. Sorry. No. I wrote something nonsense. Right. It's right beyond J. I see here, so it can grow. Right. So what is this going to be? Sorry. This matrix. I think this is 1 AI times J. So there's way too much going on in chat. I'm definitely not going to be able to answer all these questions today. Apologies, everyone. Maybe I'll start with some of these questions tomorrow. Yeah, I think it works like this. I think for this matrix, it just becomes times J. So then, so I guess we would want to take A as our constant in this case. Yeah. Interesting. Yeah, wait, there was another comment about how to expand it or something. An idea is expanding it and maybe some bounding. Yeah. Yeah, I wonder maybe if you did it inductively, because if you had like AI, well, yeah, I don't know. This is out of my wheelhouse. This is some matrix analysis stuff I haven't thought about for some time. I wonder, like, if we just thought about a naive approach. Matrix is unipotent. I mean, what do we know about like unipotent matrix and its eigenvalues? Maybe there's something there. But you're right. I don't know. We could just play around with this. Yeah, let's see what happens when we expand one of these terms. We get something like a squared minus 2a plus I. Right, so maybe because a and I commute, I guess we can basically use, like, can we use the binomial theorem here, I guess? I guess we can use the binomial theorem, right? So shouldn't it be something like k equals 1 to the j of j choose k a to the k, oh, and maybe I guess a minus sign to the k out in front, something like this. Yeah, and then the i's all disappear. Right. So now maybe we could do some triangle inequality stuff. Yeah, so for each of these sums, maybe if we bounded something about this sum, because since it's unipotent, we have these finitely many, we'll only have like finitely many of these sums being non-zero, right? So maybe if we took something about, well, if I take the norm outside, that's going to be weird. Yeah, maybe that is the right idea. But I think office hours are almost at the end here. Let me just take a look at what the questions are that I'll start with tomorrow. Have I ever had a moment where after writing up a big notebook, I want to rewrite everything in a new notebook that sequentially builds each idea? No, absolutely not. If ever anything, I write it up in LaTeX. If I want things to be preserved and in some sequential order, then I write it up in tech. No notebooks just for the rough work. Seen how product topology looks geometrically. Direct product is somehow different. Blah blah blah. How would a tensor product look geometrically? Well, Rm tensor Rn as vector spaces is Rm times n. So make of that what you will. Am I interested in philosophy of math, Platonism versus nominalism? Sort of. I mean, yes, I'm interested in philosophy of math. No, I'm not interested in Platonism or the debate. Math is a useful fiction, and if your opinion is different, it's wrong. Do I remember the Bernoulli inequality thing some time ago? Yeah, maybe we can talk about that tomorrow or something. Use the triangle inequality for complex numbers to bound it? Maybe. Hey, we used the reverse triangle inequality yesterday. Yeah. Okay, but I'm gonna end it there. Okay, so I think that was, I don't know if there's too many standing questions in chat, but maybe I'll let this sit in the back of my mind and we'll come back to it tomorrow. Hello, Paul Maurice. Bad timing. I'm about to end the stream. But thanks for joining anyways. Okay. Go prove some stuff, everyone.